All right, grade 10 math. Let's go. No, just do your math. I'll talk. If you want to talk, you can talk. Fine, I'll do it. All right, fine, let's do it. So pretty easy. So for us to determine the points of intersections, you've gotta write it in terms of standard form, or you have to use the knowledge of graphs. So we're gonna do both. For the first one, I'm gonna use my knowledge of graphing. Where's the vertex? You can help me out. Where's the vertex? No, for this one here. H and K. Yes. Minus 3 and 0. Good job. So vertex is here. We know that the vertex is on the x-axis, right? So by definition, it can only have. Oh, sorry. I apologize. Question is asking the point of intersections between the. I thought they were asking for x-intercepts. All right. No, this is easier actually. You just gotta make them equal to each other. That's it. That's all you gotta do. It's not hard. Obviously, expand this x squared plus 6x plus 9. Then we move everything to one side. 3x squared plus 6x plus 14 equals 0. And I'm going to solve this. And since they're asking for the number of points of intersections and not actually solving for the point of intersection, you can just use b squared minus 4ac. And if this is greater than 0, equal to 0, or less than 0, it tells us how many points of intersections there are going to be. You know that, right? All right. So there's going to be 2 POIs if it's greater than 0, 1 point of intersection if it's equal to 0, and 0 point of intersections if b squared minus 4ac is less than 0. So a is 3, b is 6, and c is 14. So plug them in. 6 squared minus 4 times 3 times 14. What do you get? 36 minus some really big number. 12. What's 12 plus 14? 144, 146, 168. Would you get? Negative what? Alright, doesn't really matter. You get a negative number, so it's going to be this scenario here. So there should be no point of intersections. Make sense? Sorry, hold on. You said, repeat the question. What was your question? X-intercepts? Okay, yeah. So you're right. We can use b squared minus 4ac to find out how many x-intercepts there are. But if we are given 2 quadratics and make them equal to each other, we can also use this formula to determine point of intersections between 2 lines. Do you get it? Yeah, sure, absolutely. So the first line is going to be here. You know what? I'll just use decimals. Let's just use it that way. All right, number 5. Yeah, so same question. So make them equal to each other. No, it's just b squared minus 4ac. Yep. Yep. 2 points of intersections. You got it. That's it. Okay, that's just it. Alright, so let's draw this. You got 5 rectangles, right? 1, 2, 3, 4, 5 rectangles. They're supposed to be the same size, so my drawing isn't 100% accurate, but that's fine. That doesn't matter. So we know that he has 180 meters of fencing in total, right? Okay, so 180 is equal to what exactly? Okay, yeah. So let's So if we had all of these, so we can do x and y too. It's not bad. So this is the same for all of them, obviously. So 1, 2, 3, 4, 5, 6. So that's 6x plus, and then whatever the length from here to here is, right? 2, let's say w you said. All right, so that's equal to 180. But now this is where it gets a little bit tricky because we're trying to maximize. So let's see what we can figure. All right, fine. We're gonna change up the variables just to make it a bit more easy. So we're gonna have y as our vertical points here, and we're gonna have x as these points. So now we know 180 is gonna equal 6y plus 2x, correct? And now we're just gonna solve for one of the variables. So we'll solve for x. So x is equal to what? 180. Yeah, 90 minus 3y. You're right. Equals x. Okay. Now, second thing is we're talking about area. What's the formula for area? Yes. In this case, though, our length and width are x and y, right? So area is just x times y. So far, so good. We're going to substitute this value into here, okay? Because they're both x, right? So area is equal to 90 minus 3y times y. Do you see that? And now this is a quadratic equation. 90 is equal to 90 minus 3y times y. So now that we have a quadratic equation, we can solve for the maximum point. How do we solve for a maximum point? What form is this quadratic equation written in? Is it vertex form, factor form, or standard form? No, this is not standard form. Oh, you have negative 3y squared. It's 90y. Okay, so in that case, if you did it this way, then you have it written in standard form. That's fine. If you want to write it in standard form, that's fine. If you want to write it in factor form, that's fine. It doesn't matter as long as you know how to solve for the maximum value, the vertex. I'm going to leave it in standard factor form because this is easier to solve for. You know why this is easier to solve for? Yes. We can solve for our x-intercepts this way. So our x-intercepts are 30 and 0. No, both are possible. Remember, you're not understanding. These are our x-intercepts. We're looking for the maximum value. Remember, this is a quadratic, right? So here, just so you can visually see what's happening. This is a quadratic. We have one x-intercept here and one x-intercept here. And we have to find the maximum point. Yes, in this case, this value would be 15, yes. So if y is 15, because you add 30, 30 plus 0 divided by 2, you get the average. We plug in 15 in here, so area is going to equal 90 minus 3 times 15 times 15. 3 times 15 is 45, so it's 45 times 15. And that is the maximum area. Where's my phone? 450 plus 225, 675. Alright, so that's the area. So that is the maximum area. You got it? Alright, so let's go back to the question. What dimensions should each pen be to maximize the total area? So they're asking for the dimensions of each pen. So they're asking for x and y. We solve for y. Y is 15. That will give us the maximum area, correct? So now the final thing is to now go back to the original equation and solve for x. See this right here? So what does x have to be? 3 times 15, yeah, which is 45. So my dimensions are 45 and 15. And that's how you maximize the pen. Oh, yes. Yep. So yeah, just do it. Yep. Go for it. All right, I'm just gonna talk while you're doing it. All right, so like you mentioned, maximum height is obviously, so this is in vertex form, it's h and k. So max height is 18. 18. And when does it occur? When it occurs when t is equal to 3. And in this case, I'm guessing it's seconds for thing and meters for height. So max height, and it occurs at 3 seconds. So that's A. And those are just the values that are in red here. You can see that. And what time was the baseball at a height of 10 meters? So that's a bit harder. So they're asking for t. We don't know t, but we know height is 10, so plug it in. And then solve. So we're going to bring the 18 over. That's going to be negative 18 on both sides, so negative 8.